Thank you very much. Can I please have a short confirmation that you can hear me quite well? Yeah, works fine. Okay, I'm glad to be here. Thank you for having me. I'm looking forward to a little bit more than half an hour for zero trust networking. I think it's good behavior if you come to a group and the people don't know you to introduce yourself. And this is what I would like to do at the beginning of my part of the talk. And then I will only have a few slides and we will spend quite a lot of the time of this session in demos, building some stuff in Azure. Let's see what's going on. So this is me. Oh, let me here. At least it was me many years ago. I studied computer science at a school in Austria, which is called the HTL. I don't think that's something like this is in many other parts of the world. It's a computer science high school. And I started my career doing C++ programming on the PC on the one hand side and earning my money on AS400 stuff. And then 10 years ago, 12 years ago approximately, I learned about the Azure cloud. And ever since then, I was doing Azure. I love Azure. You see the Dublin, the Ireland data center on the right lower corner. This was the first data center where we launched our first applications over 10 years ago. So yeah, I love it. I do a lot of stuff in it. And yeah, that's essentially what I do. For me, if I want to characterize myself, I'm a passionate coder. I love software as a service and cloud computing. I'm also a trainer and consultant. So my connection to Microsoft, I'm not a Microsoft employee. I'm a most valuable professional MVP for Azure. I'm an MVP for developer technologies, and I'm a regional director. But I would like to emphasize that I'm not an employee of Microsoft. So I'm self-employed. I have my own company. And if you want to get in contact with me, just go to this URL. That's my digital CV. And on this URL, you find on the right lower corner a lot of links to LinkedIn and Twitter and Facebook and GitHub and YouTube and so on. And wherever you want, get in contact with me. That's enough of the introduction. And I would like to set a little bit of context at the beginning. Maybe 5 minutes, a little bit more than 5 minutes, and then we will, as promised, directly dive into lots of demos. So yes, you will see code. Yes, you will see DevOps stuff. We will see a Linux terminal and a lot of other stuff in this session. So what is a zero trust network? Well, traditionally, if you take a look at how networks have been built over many, many years, you have this nice little cozy environment of the corporate network where all your servers are and your clients are, and maybe you have multiple subsidiaries and you have VPNs and all this stuff, and then you have the internet. And if the internet would like to access something on the corporate network, well, you have strong firewalls in front of them, and the same is true for outside. So essentially, what you have, let me move to the next slide here, you have this nice little friendship group of insiders inside the network, and then you have the bad Wild West internet out there. That's essentially the view of perimeter security as we all know it, and we have been building it for many, many years, including myself. Well, in the new world of cloud computing, that means a lot of problems. This traditional view of hard rules outside and soft or no rules inside, they don't apply anymore because there is one major thing going on. There are unicorns outside in the cloud. There are so beautiful services outside in the cloud. Users love them. Think of Power BI. Think of Microsoft 365. Think of many other software as a service solutions which simply run as software as a service in the public cloud, and users would like to access them. So building a huge wall letting nobody out accessing services on the internet doesn't work anymore. And on the other hand, these unicorns, they also would like to access some data which is stored inside of our perimeters. They would maybe think of Power BI again, access a database to build a nice little portal. That's a big problem if we only think in perimeter security. So this is something where we have to change. And the whole idea, I will skip over that because I told you that you got the link to my slides already in the chat. So if you would like to get it from there, I talked about that. Essentially, the assumption, what zero trust networking means is we cannot trust any network. All the software that we build, all the software that we operate has to be ready to be run in the public internet. So essentially, our network becomes the public internet. If we build perimeters, we build smaller perimeters. We do some kind of smaller segmentation, some call it micro-segmentation, where we isolate those things that belong strongly together, but all the other things are accessible over the public internet, and they can be approached over the internet, and they can reach out into the internet. I am absolutely sure I know what many of you are thinking. You sense a faint smell of danger. So if we want to do that, if we want to go towards zero trust networking, we have to change a lot. And we not only have to change our policies, it's not enough to change some lines in some Word documents to allow more on the public internet. We really have to change some rules. We have to think about some rules that we have to adhere to as DevSecOps specialists, and changing some rules that might be outdated when using the public internet and cloud systems like Azure, for instance. The most important three rules, if we follow a zero trust networking approach where we run more on the public internet outside of our trusted perimeter, are three rules. The first one, authenticate everything. Authentication is part of the new firewall. Authenticate every connection, user authentication, device authentication, things like that. Second, encrypt everything. There is no secure network, so we have to encrypt everything, and we have to use strong encryption. We have to be conscious about this. And last but not least, log everything. We have to log everything because we always have to assume that somebody is inside of our application, and if they are, we have to find out what they did and if they are really there. Okay? The problem here is that building applications that are really ready for being run in a zero trust networking environment is difficult. And this is why I added this GIF here. We need help. As DevSecOps experts, we need help because building such systems from scratch alone is really difficult. And the good thing is that a system like Azure can give us a lot of, let me make a little bit smaller here, can give us a hand for that. For instance, if we rely as much as possible on platform as a service and serverless, that makes things a lot easier. If we use encryption that is inside of Azure, out of the box, it makes our life much easier and trouble-free because the things are managed by Microsoft. We have a system like Azure Active Directory, which is really strong for authentication and authorization. We can simply use it. We don't have to invent things on our own. Private endpoints. If you're not familiar with private endpoints, wait for just another 5 minutes. We will dive into that topic in a second. Private endpoints allow us to do micro-segmentation, although we use platform as a service and serverless. We don't need to make our PaaS services available on the public internet if we don't have to. So we still can build perimeters around PaaS and serverless, but these perimeters are smaller. Logging, Azure Monitor, Azure Application Insight, great stuff. You will see that in a demo in a second. Network security, we could spend weeks talking about network security possibilities here. And finally, we get a secure control plane. Although we lock down everything, we can still use the Azure portal and the SDKs and the ARM and so on to manage everything. If you're not familiar with some of the topics here, don't worry, because now it's demo time. And from now on, I will do only demos. Okay, so we have 25 minutes left. I promised you just 10 minutes introduction. With that, we go right into the demos. Let me talk a little bit about my first demo. My first demo is the following situation. We have external users because we want to build a public API. Could be an API that everybody can access, could be an API for, I don't know, for any kind of open data, some product information that everybody should be able to access. And we want to have a serverless function implemented using a serverless function. So auto-scaling, we don't want to care about scaling and load balancing. Everything should run just there. But this thing is really anonymous. No authentication here. For demo purposes, I decided to store something in Azure Storage, but this is just a placeholder for any kind of PaaS service that you might use. This might be NoSQL storage, might be a SQL storage, a Postgres, a MySQL, a SQL Server, something like this. It could be a NoSQL service like a Cosmos DB with Mongo API. It could be a service like Key Vault. It could be a message broker. Any kind of, and now comes the important thing, listen closely, PaaS and serverless thing. Because I, as a DevSecOps specialist, I don't want to care for Tamagotchis out of the cloud. I don't want to pet them and feed them and update them. I just want to focus on my code, and therefore I focus on PaaS and serverless, platform as a service. I don't like virtual machines. I have to admit, I don't like them. Well, I like them because I'm also a technician. But when it comes to production, when it comes to DevOps, when it comes to you build it, you run it, I don't like VMs because I want to have a ready-made platform and let the platform provider deal with the rest. And now comes the important thing. Our serverless function should access the PaaS storage service. In this case, it's a document storage. It's Azure Blob storage. But here, we definitely need encryption and authentication. So external, okay, to the outside, but authentication with Azure Active Directory to the inside with as little security holes as possible. We'll talk about that. The big thing here is everything runs on the big, wild, bad internet. We don't have any kind of virtual network here. This is my first demo, and in, I don't know, 10 minutes or so, I will show you a similar demo with microsegmentation. But now let's assume we are really brave. We take everything and run everything on the public internet. That means, can you remember, we have to follow some rules. 3 rules. Authenticate everything. Well, not outside, because this is by design anonymous. But here, we definitely need authentication. I mean, here, we definitely need authentication. We have to, next, encrypt everything. And we don't want to care about certificates and so on. This should be done by the platform. And finally, we want to log everything. Now, let me show you how I would build something like this and how I would use Azure to build this with minimum effort. Good. Here you have the Azure portal. And the first thing that I would like to draw your attention to is this storage account. As I said, it's just a placeholder. Any kind of platform as a service in Azure, storage, message broker, whatever. This is something that runs in the public internet. And you know what? In my experience as a consultant, this is really a challenge for many enterprises because I've seen an endless number of enterprises that told me we have a policy that says no storage system where we store business critical data is allowed to have a public IP address. Well, a storage PaaS system like this has a public IP address by design. That's the whole idea of zero trust networking. And therefore, I've seen many companies, I'm not saying that it's the case for your specific company, but many companies, they don't use PaaS and serverless services because these things have public IP addresses. They build the things locally in their own VNets without public IP addresses, but with much less security built in. So my assumption here is, why not use PaaS and serverless, rewrite the policies, and check whether the mechanisms that are built into these storage systems, into these PaaS services, are enough for our purposes. Let's see. So the first thing that I would like to show you is the whole configuration stuff. If I take a look at the configuration, the first thing that you will see here is that all these PaaS and serverless services in Azure, we're talking about Azure today, they have a lot of security settings that come by default. For instance here, if you turn on this thing, security, SSL, TLS certificates are enabled and enforced by default. You cannot access this thing without a TLS certificate. It's just there. You cannot opt out. Or here, when creating this storage account, you can immediately disable public access. So nobody can accidentally allow public access on data which is stored in this storage account. So the point that I want to make here is you have to configure these things properly. You have to check these configurations automatically. I think this will be covered in the second part of this talk. And when you do that, it's not crazy to run something like storage or SQL or message brokers in the public internet. It's okay. They are built for zero trust networking. This thing runs in the public internet, and let's take a look at the public function. This is a serverless function. I've built it for today's presentation. And the question is, how can now the serverless function access storage protected by Azure Active Directory? Because we said authenticate everything where it makes sense business-wise. If I try to, for instance, access a blob storage directly over the public internet, I can show you that. I have copied the URL here. Believe me, it's from that storage account. Then I get the message, public access not permitted. So it's available on the internet, but it's not accessible through the internet because we have to provide authentication. The question is, how can we authenticate? And the point that I would like to make here is identity here. This magic flag, identity, I always call it Harry Potter programming. Like, take a little bit of fairy dust, put it over your app, and it magically works. It's something like this. This is called managed identity. Managed identity means that we can just turn on a switch, just this switch, not more, and then this app can, as itself, without having to provide any kind of secret, token, client certificate, open ID, interactive flow, refresh token, whatever crazy stuff you can imagine in security-wise, it is no longer necessary. It's really as simple as that. You just turn on system-assigned identity, and then this serverless function can access all the systems where I give it access to. In this case, I demo-wise gave some things, for instance here, storage blob data owner for our storage account. It can, out of itself, access these protected resources. And code-wise, it looks like, let me see, here, this one. If as a developer, I would like to specify credentials to access the blob, all I have to do is say Azure care for it. Please take with you, in this middle tier, in this serverless function, there is no secret, no client cert. You cannot check it in accidentally in a source code management system. You cannot lose it. Nobody can take it away from you. It's just stored. It's managed by Azure. It's rolled over by Azure automatically. We simply don't have to care for it. And that's really powerful if you have this. Okay, let me try and access this function. I copied the URL. Let me show it. And if it will say something like hello world, let's see. Here it is. Yes, it worked. So what we now did, let me quickly go through our slides. What we now did was we came as an external user to the serverless function. The serverless function got a token from managed identity without the necessity to store any kind of token or secret, gave this secret to storage, and storage verified this secret from Azure Active Directory, said, okay, the serverless function is fine, we are good, and answered with the content of the blob. This is what we did. No secrets, everything encrypted. So, ready, our application is definitely ready for zero trust networking. What about encryption? Storage, data encryption at rest? Check, that's done by Azure. That's true for all the storage systems. What about transport encryption? I already showed you that storage has SSL TLS enforced. What about the service side here? It has SSL enforced, so we encrypt everything here too. Now this is a default DNS from Azure, but you can add your own DNS name, and Azure will care for manage the certificate for you. So you do not need to refresh the certs, store the certs, you cannot lose the certs, they are just always up to date, and you don't have to care for it. That's the important thing here. So next one, encrypt everything, check, also done. What was the third thing? Log everything. So what did I do? If I take a look at the serverless function here, and if I take a look at application insights, then I just flipped a switch. I did not write a single line of code for that. I just say enable. And then I can go to this so-called application insights. Application insights is the monitoring the monitoring component in Azure for monitoring applications. Now let's go into the public here and let's check what we have in the last 24 hours. So we have a lot of requests, as you can see it here, and there is a message done processing the request. Where does it come from? Let me quickly show you the code. It's just a single line here in my code. That's the C#, by the way. It's just a single line. So yeah, it looks like we log everything. But can we dive a little deeper? Yes, we can. If we click on that, then you see this trace. And the beauty here is, with application insights, that we really get a deep dive into what's going on in our environment without having to write code for that. So what we see is that we got an HTTP request to our serverless function. This serverless function went to managed identity and retrieved an access token from Azure Active Directory for accessing storage. And with this token, it went to storage and got the data from storage. So we can really dive into the details. We can see where exceptions happen. We can do timing, and all these things are automatically provided by application insights here. And if we, for instance, go here in the application map, we also see what's going on in a graphical way. Okay, that's not super exciting when we talk about this graph, because this graph is really small. We only have our client, which is my local machine. We have Azure Active Directory, and here we have the storage. But you can imagine if you build a larger application consisting of many microservices, this view is super, super important because it gives you a good view what's going on, what the timings are, how large the failure rate is, and things like that. And that's all important when it comes to monitoring a system that runs in a zero trust environment. So what did I tell you here? 3 rules: authenticate everything, checked; encrypt everything, checked; log everything, checked, without us having to write code. Second example. Second example is a little bit more like you might maybe build a system in your real life. In this case, I have an authenticated user. We don't have an anonymous user anymore. The user has to authenticate against Azure Active Directory. Still, we have a serverless function, but now the serverless function, it is available on the public internet, because our authenticated users might work from home, they might work from a supplier, they might work from a partner, whatever. But the serverless function would like to access storage, but this storage system should no longer be available over the public internet. It should be locked, not in terms of the IP address. Storage still has a public IP address, but it's locked down. Nobody can access it. But what we can use in Azure, we can use so-called private endpoints. We can map an local IP address inside of our own virtual network, and then our serverless function will use a local IP address to access the private endpoint through our local VNet, through our local IP range. Storage is still out there, but it isn't the problem anymore, because nobody can use the external IP address to access storage. So what we now have is we have the big wild internet here, and we have this cozy friendship inside, but it's a smaller perimeter. It's just around this one application. Every application, every microservice, every group of microservice can decide how the perimeters should be designed. And now I would like to show you how I created that, how I solved that one. Again, we need to have, let's quickly go back, authenticate everything, encrypt everything, log everything. Let's see. Let's go back to Azure, and let's go back to our resource group here. The first thing that I would like to point your attention to is this one. This is our virtual network, and if I go to the, where is it, subnets, here are the subnets, then you see that I created a bunch of subnets. I have a subnet where, for instance, a demo virtual machine. Yes, I will use a virtual machine for this demo too. It runs here. Here I have a subnet for all the private endpoints. I'm using a system which is called Bastion. You will see that in a second. And I have created a separate subnet for running my serverless functions. So we have a virtual network with a bunch of subnets, and of course you can add firewalls, you can add DDoS protection, you can add a lot of other stuff that I don't have time today to dive into, but it is there. This is the whole network security universe of Azure, and we could talk for days about that. Now, let's take a look at the storage, because I created a second storage, and this storage should not be available, or at least very limited available on the public internet. And therefore, I connected my storage system, you see it here, through a private endpoint. You see this private endpoint here, through a private endpoint to my virtual network. You see it? So this storage, it is in the public internet. It lives in the world, in the wild west of the internet, but it has an endpoint inside of our virtual networks. That's the important thing here. The second thing that I did is I turned off allow access from all networks. So it is simply not possible anymore to access this storage through the public internet. It's not possible. It's only allowed to access it through selected networks, but I did not select any network because I don't even want to enable it for any external VNets. I just want to enable access through the private endpoint with a private IP address. I could selectively allow certain IP addresses or certain VNets to access the storage account if I want. You could, for instance, create a rule that allows people to access the storage account from within your home base, your corporate network, your local area network, but from at home, they shouldn't be able to access the storage account. You could configure that very easily. Good. That's the virtual networking stuff. I can prove that this does not work, so I copied the URL, and this should not work. You see, not allowed. We cannot access this private blob here. It's not possible. Now let's check a little bit about the name of the service here. I have my Ubuntu running here, and I will do a dig on this storage account. That's a PaaS service. Again, a platform as a service service. Here you see that's a DNS query for storage VW Azure Day Private Blob Core Windows Net, and what we will see is we get a public IP address on the internet. That's the public IP address. Can I access it from here? No, because I have firewalls. Now, what happens if I'm inside of my VNet? What I did in order to demo all this stuff is I created a virtual machine, this virtual machine here. This virtual machine is not accessible in any way over the public internet. It is completely locked down. It does not have a public IP. You see that? It just has a private IP, but still I would like to access it. I would like to play around with this little Ubuntu system to check, for instance, the DNS configuration. And the beauty here is that I can very easily connect using a system which is called Bastion. Bastion gives me, if I click on that, a browser window where inside of the browser window, I get SSH or RDP access to my virtual machines, to all the resources inside of my VNet. So I'm not using SSH to SSH into my Linux box, because that would mean I have to open it up on the public internet. No, this is inside of my perimeter, and with Bastion, I get, let's say, a window into my VM. And here, we will do exactly the same dig command again. And let's see what's going on here. Now, this is a beauty, isn't it? You see, 10.0.1.4, now we have a private IP address. And how is this magic done? Well, internally, if you create a private endpoint, internally, Azure creates a private DNS zone. Inside of this private DNS zone, it creates a CNAME, which points to the same name but added private link here. And this private link stuff then points to a DNS entry, an A record, that really resolves to the local IP address. So if you are inside of the VNet, you access the storage through the local IP. From outside, you access it through the public IP, but this is locked down. Okay? Hope you get the idea. So this is now a smaller, let's say a micro segmentation for our storage. Okay? I can show you now how we can use the virtual machine to access our blob, which is stored in the private storage account. If I would try to access this storage account, I have to copy that here. Copy. Here we are. If I try to access something from the storage account, it will not work. You see, because I'm not authenticated. I told you, encrypt everything, log everything, and authenticate everything. So we need to somehow get an access token. But what did I tell you? I want to have fully managed identity. Now, the magic behind managed identity is that every virtual machine gets an endpoint, not only virtual machine, but also serverless functions and so on. And this endpoint listens on this IP address. It's the same for all Azure VNets on exactly that IP address. And you can ask Azure to give you a token which allows you to access resources. So behind managed identity is in the real life a service from Azure where every virtual machine, serverless function, Kubernetes cluster, and so on can go to this IP address and say, I need a token. And then they check the configuration in Azure Active Directory and give the system a ready-made token that it can then use to access, so for instance, a storage system. I can show you that if I run that. For those of you who are deep technical, that's a jaw token. I'm quite sure you see that. I can also assign this to a variable. Let's do that. So now I have it in the token here, echo $token, and you will see this is the jaw token. Let's inspect that one. I've installed a jaw token viewer, and you see that's really an access token that has been provided for my app. Here you see the representation of my managed identity app. It was given to me by Azure, and now I can use this token again to access my blob storage. And I will do exactly that. I have the same curl again to the hello world, but this time I am injecting my Azure provided token. I don't have any secrets again here. I provide the token that I got through managed identity, and we get back hello Volkswagen from Azure. So we can now access it. If I go quickly back to my slide here, that means that this serverless function gets a key from Azure without having to know any secret and can provide this key to the storage system. And last but not least, and then I am done. Then I'm also perfectly in time because I only have 3 minutes left, but it's always a good thing when content is at the end and time is over. So that's the last demo. Hopefully it will work. What I did for the last function here is I added this function. I show it to you here. I added it to my virtual network. You see? So here we are. Oops, sorry. Here we are in our virtual network. So this function is now accessible over the public internet, but it can also access my VNet. So it's both. It's internet and VNet at the same time. And it will go through the VNet to access storage. I will prove that. Last but not least, the user should be able to authenticate. And that in Azure is again something what I really love because it's again platform as a service. All you have to specify is that you would like to have Azure Active Directory integration. It's one click, just say yes, and that's it. Everything else, the whole OpenID stuff is done automatically. You do not need to care about that at all. You just get the ready-made token, the ready-made claims, and so on. Now, hopefully, crossing fingers, the last demo will work because now I'm accessing this function. And let me show you that I can access it really in a private window. So let's run this guy. You see that one? I accessed my function, but the function was now the load balancer in front of the function, which was not written by me. It was completely done by Microsoft. Just by clicking this button, authenticate, it redirects me to my Azure Active Directory login. Let me quickly log in. Of course, you have now all the beauty of Azure Active Directory. You can, for instance, do multi-factor authentication. Let's do that. Multi-factor authentication, here it is. Good, multi-factor authenticated. Oh, I need to provide my fingerprint. I will do that. Good. And that will give us, you see, now back to our function. So Azure Active Directory protected my serverless function without me having to write a single line of code. And here, just for demo purposes, if you are interested, I can show you the code. I am, for instance, reading the token, the ID token for the OpenID security experts in the room. I'm reading the ID token and I know the name of the user. I have the token for storage. You see here the DNS query. I did a DNS query here in this code. So you see I'm really accessing storage through the local IP address. And at the end, this is what I wanted to see, the content of the blob. So with that, we have, let's see, Azure Active Directory authentication from here without us having to write code. Then from here, access over a local IP address through private endpoint, getting the token through managed identity, and locking down access from the internet here that should not be available through firewall policies. And that makes our application ready for running in a zero trust environment. This is what I wanted to show you, and I hope it was interesting. I hope it wasn't too technical. For those in the room who don't like Linux terminals and OpenID and tokens, bear with me. I hope you got the idea. For those of you who are passionate DevOps coders like me, I hope you saw a little bit of code and that made you feel well. With that, thank you very much. I can answer any question now, or I can hand over to the second speaker of this talk.